Okay, the SLOOH Space Camera show will begin in about 4 minutes. About 4 minutes. The SLOOH show is going to begin at T-minus 3 minutes. How did the Paul? How did the animation come out? Just curious.
Yeah, good.
Good. I'll get that out after this.
Yeah, I mean it's not as fast, obviously, as the other ones, but yeah, it looks okay.
Cool.
It actually comes up to a little galaxy. We didn't actually see it. It's in the images now as well. We've got a little background galaxy in there, which is looking pretty cool.
Oh, that's good. Let me just double check a few things. Okay, the SLOOH show is going to start in about 2 minutes. Make sure I always forget to turn off my phone.
Oh, that was yours, was it, in the last show?
Yeah. As much as I tell my wife, don't call me during a broadcast, it doesn't matter, man. She's always on. It's pretty funny. All right. Okay, we're going to start the SLOOH show with T-minus 1 minute. 1 minute. SLOOH show will start in 30 seconds. Hi everyone, this is Patrick Palucci from SLOOH Space Camera. Thank you for joining us for show number 2, tracking Asteroid Apophis. It is January 9th, 2013. Thank you for joining us for our broadcast tonight. I'm here with longtime SLOOH outreach coordinator and engineer Paul Cox. He will be commanding our observatory in the Canary Islands. If you don't know where the Canary Islands is located, it's off the coast of Africa. We had a show earlier today, and due to the amount of interest worldwide, we decided to implement a second show. So I hope you guys are going to enjoy the view. Right now, if you're on the homepage of SLOOH.com, you can actually see the asteroid zipping through the sky. Now, as Paul outlined in the first show, and he'll screen share it in here for us quickly, so I'll make sure you guys can see it on the Hangout here for a little second. The best presentation is going to be on SLOOH.com. You can also see this Hangout interaction as well, but it's a little bit clearer view. So if you go to SLOOH.com, you can see this image. That round dot you're seeing in the middle among the trailing stars is going to be the asteroid. Now, this particular asteroid, the reason why it's so of interest is that it's not necessarily what's going on tonight, but what's going to be going on in 2029 and 2036, and that's why everyone's a little bit freaked out about this one, and that's why SLOOH is covering it live. For those of you who don't know much about SLOOH, we own and operate our own facilities worldwide. We have a world-class facility in the Canary Islands for membership. And if you've not ever thought or ever know much about SLOOH, click that Join SLOOH Today button that you'll see on the homepage of SLOOH.com and learn more about becoming a member. You'll get a chance to command robotic telescopes. You get the chance to interact with members worldwide. And it's for all levels. And in addition to all that, it supports all the live programming we do on the homepage for free. So here we are, Paul, on show number 2. What can you tell us right now about the asteroid that you're seeing right now as you continually track this tonight?
Yeah, well, I've just tracked the satellite again. I've just managed to pick it up again, the asteroid again, and at the moment it's showing on the home page. It's I believe, I'll confirm this in the next image, but I believe it's the bright object just below center. So I've got to the later images. Once everything's settled down, that I think it'll become more obvious. But the interesting thing to point out there to everybody is what we're seeing there is there's a little galaxy as well in that image about the kind of 10:30 position. And you can see a kind of long cigar-shaped thing which is slightly brighter in the middle. That's a background galaxy. All of the other white dots that we can see in the image, those are stars in our own galaxy. And the spot which is going to stay stationary on every single image that we see, that's the asteroid. And I'll be able to confirm that a little bit later on when I'll just screen share that in very quickly, and I'll point to where I believe it is. So this is the one that we believe is the asteroid. I'm waiting for another image to come in to confirm that. And then we've got this little galaxy just showing up here, which is really cool. And we'll see that slowly move across the field of view as we pick up more and more images.
Do you know what galaxy that is by chance, Paul, or is that too remote?
No, it's such a tiny one. It's probably got some obscure catalog number. Maybe one of the SLOOH members can have a quick look and post that into chat if they can find out its reference. But it is literally a very tiny background galaxy. You know, it's so small.
Right. That's awesome. Yeah, so guys, we're tracking this live on SLOOH.com. Now, this particular asteroid, for those of you who don't know, is about 270 meters plus across. They keep tweaking it a little bit. I noticed that there was a release today that's a little bit bigger. But that, for those of you in the United States, that's about 300 yards, or equivalent now that's football playoffs out here in the U.S. It's 3 football fields big. So imagine this thing right now is whizzing through the space. It's about 3 football fields big, and it's 9 million miles away. So Paul is actually tracking this thing 9 million miles away. It's 3 football fields big. So it's pretty small, but it's pretty cool to be able to do this live. And one of the things that we were talking about in the earlier show, and we had Duncan Kopp on, who's a filmmaker, documentary filmmaker who does a lot of space and science themed documentaries for Nat Geo, Discovery Channel. He's made films, award-winning films and such, and we were talking more about it. And you know, the interesting part about this is not necessarily what's happening tonight, and that's not why really the media is covering this so actively. It's because what's going to happen down the road. And in 2029, for those of you who don't know, this actual asteroid is orbiting our solar system, and it's estimated, and this will get tweaked as years go on, I'm sure, but it's estimated it'll be about 30,000 what is that, kilometers away, which, in reference to that, that's about where our geosatellites are located up in above Earth. So it's going to be coming in much closer.
In 2029, Pat, it's 23,000 miles away.
23,000 miles away.
Yeah, so on the close approach, which is going to be in 2029, that's it. And to compare that to tonight, it's 22 million miles.
Right.
No, it's not. Sorry, it's 9 million miles, 8.98 million miles tonight. So
right. It's going to be quite fascinating. But the big concern now, this asteroid was actually discovered in 2004, so we've known about it. And at the time of the discovery over at Kitt Peak Observatory, they were concerned that there was a 1 in 45 chance that this would hit Earth somehow in 2029, but that's been revised. But the big concern is 2036. And that, they're saying right now, and it might get adjusted, and hopefully it does for the better, but they're saying 1 in 250,000 it could hit Earth in 2036. Now, if that does happen, and we don't, we're not sitting here promoting that it's going to, but if it did, they estimated this would be about 100,000 Hiroshima nuclear bombs, is one estimate I saw, exploding all at once, which is quite significant, as you can imagine. So even an object this small, really, I mean, it's really not that big if you think about it, could do a significant damage into Earth. And so that's why it's so much of interest, and hopefully the experts who are tracking this over the coming days will enlighten us with more information about what is really going on out there with this particular asteroid.
Well, it's us as well, Pat. It's SLOOH and SLOOH members. We're going to be submitting, we're going to be measuring the exact position and the exact time where the asteroid is in these images, and we'll submit that to what's called the Minor Planet Center. And it's the Minor Planet Center who use all of those observations, put them together, and they do what's called, they come up with a solution, an orbital solution, and that changes with each observation coming in, and that's why the predictions for this particular asteroid have changed so much. In between the 23rd of December, when it was discovered in 2004, in the 7 days following that, the predictions went up and down wildly. It was astonishing to see just how much the predictions were varying as each new observation came in. And it wasn't until when was it? In 2005, it was calculated that if it passed through this really tiny region, that it could impact on the 2029 approach. And that was when it was given this 1 in 45,000 chance. Then, over the years, in 2005, there were further observations made, and then finally in August 2006, its hazard level was lowered, because this particular asteroid has been the highest classified dangerous asteroid in what's called the Torino scale. This asteroid hit level 4, and no asteroid has ever before or since ever hit that level. But it has now certainly gone down to level 0, which means that there is no immediate threat. But we still have this potential threat on one of the later passes, and that's the, which one are you saying, Pat, the 2036?
Yeah, that's what I was reading.
Was that?
Yeah, correct.
So we've ruled out that this thing could hit Earth in 2029. We know it's not going to hit Earth tonight. I mean, it's 8 million miles, 9 million miles away. But it's just been fascinating to keep watch on how these predictions have gone up and down as each new observation flies in.
Right. Well, if you're joining us right now, you're with Patrick Paolucci and Paul Cox from SLOOH. We're tracking this Asteroid Apophis live on SLOOH.com. You can certainly watch the Hangout in YouTube and G+ if you'd like. Paul will be screen sharing this images in directly from our homepage, but you can just go to SLOOH.com. He just posted something there, and you can watch this event on SLOOH.com with the Hangout panel there, and it's a little clearer. The reason why we do that, especially for asteroid events, it's tough to see them in the Hangout environment because of the streaming stuff. So, but anyway, if you're on Slooh right now, you can see the asteroid. It's that round dot in the middle of the screen with the trailing stars. And Paul was actually pointing out a background galaxy, and you can still kind of see it there as well, which is kind of fascinating. It's a galaxy that's not necessarily you have to look it up to really figure out which one it is, but it's pretty remote.
Yeah, it's very, very faint and very small.
Faint. Exactly. So, but anyway, if you guys are on our homepage, we'll try to monitor the Slooh conversation section. I know people can ask questions in YouTube and Google Plus and stuff, but it's very difficult for us to monitor all of them. So just go to slooh.com, click the Slooh conversation box, and you can type in your question there quite easily. Also, if you want to follow our events, we do a lot of different shows. This show is obviously of interest right now, but we do a lot of different stuff throughout the weeks and months. And, they're always counting down on slooh.com. So please either come back to Slooh or subscribe to our Twitter feeds or Facebook pages or G+, whatever your preference is. You can keep updated on upcoming events that we produce for free. And, of course, there's membership, and membership to Slooh is about a lot of different things, and one of them is supporting this type of programming. It's also about commanding the robotic scopes that Paul's commanding tonight. And we have a world-class facility that we've been around since 2003, and if you're a beginner, all the way up to the guys who want the FITS data, which if you don't know what that is, you probably, it's over your head, so don't worry about it. But that kind of we service a big market for Slooh, and please consider membership. And if you can't afford that, a contribution of any sort is always appreciated to help fund guys. The experts we get on, guys like Duncan and Bob and others who come on, these are paid professionals. They don't come on because they want to obviously educate, but they're paid professionals, and we got to pay them. So that's the bottom line. But anyway, not to mention Paul and myself, of course. But anyway, as we are going through this, Paul, this is our second broadcast, and we wanted to do the second one. I'm seeing this thing. I'm looking at this live on my iPad. So if you guys have a mobile device, an iOS device, an Android device, you can watch Slooh shows on those devices as well. And in fact, the iPad app, which I know I've been talking about, is going to be coming out soon. It's I'm moving into testing phase very shortly.
It's going to be so awesome. Just to let people know, Pat's been working on this for maybe 6 months or so, and the telescope that we're using tonight to view this asteroid whizzing across the sky, you'll be able to control that directly from this app with virtually a single touch, isn't it, Pat? I think it's going to be so cool.
Yeah, it's going to be cool. I mean, I have to say it's pretty neat technology that we've implemented with it, and I have been working on it a long time, and it's got delayed because of some of the technical challenges we had to overcome, but I am thankfully saying, very close to getting into that out. So keep your eyes on that as well. We'll announce it when it's ready to be downloaded. It's going to be a free app to download, and you'll have access to this type of program, but you'll have to pay for other stuff. If obviously it's tied into being kind of a member to some extent. So anyway, all right, guys. So here we are. If Paul's screen sharing it in again, Paul, why don't you cursor it? So if you're watching this on the Hangout,
it's the round white dot. So what we're doing is the asteroid is moving against the background stars, and actually I can tell you exactly how fast it's moving. Its relative velocity is over 9,000 miles per hour. So the telescope is pointing towards that asteroid, that dot, and it's tracking at the same time, the same rate of motion as the asteroid, which is why the stars in the background are streaks, because the asteroid is moving against the background stars, and we can see the galaxy that we've got in the view that started off far over on the left is slowly moving over to the right as the asteroid is moving east. So
right now this is
moving west, actually.
This is awesome. So here we are. I'm I'm going to send out a tweet really quick, Paul. So maybe, I don't know if you have anything in particular. I mean, we talked a lot of different stuff in about this asteroid. Why don't you give us some factoids that you mentioned a few things already, but go ahead and spout away while I tweet out about this event.
Okay, well, there were a couple of people that emailed me in between, and thanks for that. You can always email me on any of these events. It's coxy@slooh.com, coxy@slooh.com. Always love to hear from people. But a lot of the questions were what we were talking about, the potential impact consequences. What are the consequences of an object this big actually hitting Earth? So we've already said and we've already established, look, this thing's not going to hit us tonight. It's 8-9 million miles away. Even on its next path, it's still going to be 23,000 miles away, so it's not going to impact in 2029. The uncertainty is a decade after that. But what we've done on SLOOH, and last year was a classic example of this, we saw a whole series of new potentially hazardous asteroids, and that's what this classification is on this one. It's a potentially hazardous asteroid, which means at some point in the future it could impact Earth. Last year in 2012, there were about half a dozen near-Earth asteroids that were discovered literally days before they were making their closest approach to Earth. Now, that surprised an awful lot of us who have been watching this stuff for a very long time, not least because a couple of these asteroids were actually really pretty big, far, far bigger than this. In other words, miles across, not meters across. So going back to that question that I was asked, what if an object of this size, of Apophis, hit Earth? So we're talking, the range is, I think the most up-to-date estimate of its size is about 310 to 340 meters. So we don't know the shape of it, we don't really know the size of it, we estimate that from its brightness. So if that was to hit Earth, then it's going to basically devastate thousands of square kilometers if it hit ground. If it hit the ocean, either the Atlantic or the Pacific, it would cause probably greater damage because of the tsunamis that it would create. Now, we already know in this later pass, in 2036, that the path that it will take will, if it was to come in, it would be around the time when Colombia and Venezuela were facing that part of the sky. And it's estimated that there would be 10 million casualties if it hit areas as populous as Colombia and Venezuela, and those are not highly populated areas. Then we want to put it in context as well, Pat, about what's the explosion like of this thing. An Apophis, if it hit land, would be the equivalent of 510 megatons of TNT. And to put that into perspective, when Krakatoa erupted, that was only 200 megatons, and that was virtually felt and heard around the world. It was heard hundreds of miles away. The biggest hydrogen bomb we've ever exploded, which was called Tsar Bomba, that was only around 50 megatons. So if Apophis or a similar asteroid of this size hit Earth, it would be 10 times the explosion of the largest hydrogen bomb we've ever exploded. So it's going to do quite a lot of damage. But the other important and nice thing to think about with this one is that it's not big enough to cause any long-lasting damage, and that's what's important to us. It's not going to give us a global winter, a nuclear winter. It's not an extinction level event like you see in the movies, but it would cause some fairly widespread devastation. So, you know, but we know it's not going to do that tonight. So
you're basically
trying to cheer the mood.
You're basically telling people right now, Paul, not to buy real estate in Colombia or
Colombia. Actually, I don't think I want to badmouth Colombia or Venezuela at all, do I? Really? No. They're both very lovely countries, and people should heavily invest in real estate in both of those countries.
Exactly. So if you're just joining us, you're with Patrick Paolucci and Paul Cox with SLOOH. We're tracking live Asteroid Apophis. from the Canary Islands off the coast of Africa using one of our observatories. You can see these images live. Paul will screen share them in every so often, just screen sharing the homepage of SLOOH in. So you can just go to slooh.com if you'd like. Here, I'll even put it up here, and you can see it and get an idea of what I'm talking about. But this is where the live imagery is feeding in, and you could see those arrows up there. There's different channels. Now, a lot of our shows, we have multiple feeds. This one, I think we only have a couple, all sky and just the image itself of the asteroid. But for others, we'll have multiple shows, and we can pull feeds from all over the world, including non-SLOOH observatories, which is pretty cool. So if you're an observatory guy out there with high professional equipment, email Coxie at slooh.com, and he can evaluate whether or not you'll be a good fit for our systems. And but anyway, so here we are looking at some live images. You can go to slooh.com and look at that stuff. This particular show is going to be 35 minutes. So Paul, I extended it 5 more minutes because time is flying by on us. So we got 15 more minutes in this particular broadcast. And as I mentioned before, with all these broadcasts, you can see them counting down. We don't just do we do shows weekly, really. And we've got experts in the field like Paul and Bob Berman from Astronomy Magazine, Duncan Kopp, Dr. Lucy Green, others who come on and talk about what's happening, but they do it usually with live feeds. That's how we usually operate, so it's pretty cool. Anyway, Paul, so here we are. I'm looking at stuff. I'm going to look at the chat box and see what people are talking about.
Okay, you have a look at that, Pat. Check for any questions, because I've got a couple of questions that I had asked before in the last show that we didn't get to. Somebody was asking, can we see this with the naked eye? No, you need a really good high-power telescope. I'm just sharing in the homepage at the moment. If you look at the all-sky camera view, somebody asked, where is it at the moment? Well, you see where the little live word is down there? It's about here where my cursor is wobbling here. So it's quite low in the south, and you can see the images are quite noisy because this pink stuff here, that's cloud. But the other thing that I thought was pretty fascinating, and it was a little factoid that I did pick up on, is on the 2029 pass, because it's going to be so close, it's going to be closer than these geosynchronous satellites, it's going to be very, very bright. It's going to be what's called magnitude 3.4. Now that means we'll be able to see it with our naked eye. So on this next closest approach in 2029, we're all going to be able to go outside, look up with our naked eyes, and we're going to see this thing move, and we'll be able to watch it move because it's going to be moving about 42 degrees every hour. So that's going to be pretty cool to watch. That was a little fact.
Wow. Paul, I only plan about 1 day in advance, so I'm not sure I could. 2029 is a little bit out there, man. That's I'm gonna be an old dog by that time.
But it shows the difference there, Pat. That tonight to see this, we've got to have a really high-powered telescope and really expensive CCD cameras to see it. But when it's so much closer, it's going to be so bright in the sky that we're going to be able to watch it cross the sky with our own eyes, just pop outside. And in fact, I think the bad news for you, Pat, is that you're not going to be able to see that from the USA. It's mainly Europe, Africa, England, where I am. We're going to be able to see that. So maybe you'll have to pop over.
Well, when people always say that to me, I always say, well, thank goodness for SLOOH. That's what SLOOH's for, man. You can go to SLOOH, watch it live. So anyway, we're watching this live on the homepage of slooh.com. Thanks for coming tonight and checking it out. This is show number 2. We've got a large audience who is interested in seeing this particular event. Tonight, as we've outlined, this object right now is about 9 million miles away. It poses no threat to the Earth right now. But you can see the orbit right now. If you go to SLOOH in the box number 2, that was provided by NASA JPL. You can see these orbits of these asteroids, and it's kind of neat to see how it is in relation to the Earth. You can watch that there, and but what was Paul's alluding to in 2029 and 2036 is the big concern. So, it's when people are a little bit freaked out about what may happen with it. Now, one of the things that always freaks me out, though, are the ones we don't know about. We know about this one, and last year, Paul talked about this a little bit in the last show. We covered at least 3. I don't know if it was the more, but we had at least 3 that were pretty big that we
Yeah.
didn't know about, and they were like 2 to 10 days notice that came
Yeah.
ripping into town. And fortunately, they were close. I think one was within 10 lunar distances or something like that, if I recall. Maybe that was LZ1 that was that close. I
Closer
can't
than that,
remember.
Pat, I think. Yeah.
Yeah, it was close, and we covered that one live, and it was an amazing event because it was actually 3 days notice. We covered it live. It was fortunate because of the weather and all that. And we had the guy who discovered it came on the show, man. It was pretty cool, and we talked about it. But it also made me a little concerned because I was always of the mind that we knew these things for the most part in advance, and that was an eye-opener. And not only that, it happened multiple times last year. So hopefully
Well,
that's...
the other fascinating thing, Pat, about last year is we not only saw those ones, which were potentially hazardous asteroids, which were discovered just days before they were making their close approach to Earth, but we also saw, I think it was was it September? It was in September, October. We were doing the month of live astronomy, which was a fabulous thing. We did 40 nights of live shows here on SLOOH, and one night we watched a comet or asteroid slam into the atmosphere of Jupiter in this humongous explosion.
Right.
There was this enormous flash. When this asteroid or comet, we don't know what it was because we didn't know that it was going to do it. The only sign of it happening was this enormous explosion that was caught on video camera. And we tracked it over the next few days, and we didn't see the soot marks that Shoemaker-Levy 9 left when it broke into 20 or so pieces and slammed into Jupiter. But the point being is that's just last year. So we've seen that these things don't always miss their target. Now, Jupiter obviously has a huge gravitational attraction to objects like that, far, far greater than Earth does. So these things are naturally sucked in. In fact, Jupiter's often called the vacuum cleaner of the solar system because it does actually save a lot of these asteroids reaching Earth. But we've seen it. We've seen asteroids or comets hit other objects in the solar system just last year, in the last few months. So, and this is not about a scare story. This is about saying, wow, this is really wonderful. We shouldn't be scared of it because frankly there's nothing we can do about it anyway, but isn't this a wonderful place where we live on Earth with these asteroids and stuff whizzing around this dynamic solar system? And it's awe-inspiring when you actually start getting to understand. We might look at these images that we're seeing tonight and we might say, well, it's just a little dot on the screen. Yeah, but if you think about, look at that and see what it's actually doing. We're watching this lump of space rock, all right, which is 4.5 billion years old. It's as old as our solar system. So, as Duncan said, asteroids are kind of the builder's rubble from the inner solar system formation. Comets are like the builder's rubble of the outer solar system. So that bit of primeval rock is older than the Earth. It's 4.5 billion years old. We think it's about 310, 340 meters in diameter. We know that tonight it's 8.98 million miles away. But we're able to point a telescope at it and watch it move against those background stars. And in that same image that we're looking at on the home page, we're seeing it whiz past a background galaxy as well. How cool is that? You don't need the newspaper headlines to make this an absolutely awe-inspiring event. It is. It just is.
I agree.
Sorry, I was on my soapbox there a bit.
You're getting very excited, Paul. You're very excited for a guy. It's 2 in the morning.
This stuff does excite me because it is. We never know from night to night what we're going to see. We had that wonderful comet last year, Pat. SLOOH members were watching it every single night. They were pointing the SLOOH telescopes to this comet 168P Hergenrother, and it had mysteriously brightened. Nobody knew why it had brightened. We thought that it might be breaking apart. We monitored it over a couple of months, and indeed, in the end, it broke apart. And this stuff just comes from nowhere. You can be looking at Jupiter and suddenly the great red spot kind of darkens or gets bigger, or a new storm erupts on the surface or something like that. There's always something going on. It's certainly not a static place up there when we look in the night sky.
Yeah, so guys, we're back. We're down to the last 5 minutes of this broadcast, and what we'll do post-event is we'll put up some animations of this thing zipping through the sky that you can check out later today. I do want to point out that membership to SLOOH does fund all the programming we do, but you get this opportunity to learn more about space, command our own robotic scopes, and it's for all levels, for kids even. I mean, we've got a wide range of membership to guys who do advanced fits type work. And it's a great community, and some of you out there are asking, how do you go about tracking this stuff? How do you even know where it is? You know, these are things you learn in the SLOOH community. I mean, that's what it's for. I mean, that's where you can ask these kind of questions, and you get them answered by guys who are really into it, and it's really neat because it's a way for people to learn more about our solar system and also deep space, galaxies, nebulae, all that stuff. So it's kind of
Pat, it's also important to point out though that, you know, when you first join SLOOH, you don't have to worry about coordinates or anything like that. You go into the interface that we've built, right, and you just select from a list. You say what time you want to point the telescope. It will tell you when and what objects are visible. So you can just pick it from a list. And SLOOH does all the image processing and stuff like that. So, Pat, I thought I'd give you a little bit of a treat in the live show at the moment. I'm just showing you the little animation that I put together from the images from the last show. So this is a lot easier to see its movement over the sky. And actually, if you look at this, you just see another background galaxy just coming into view on the left. So hopefully some of the news channels might pick that up for us, because it is important that we get SLOOH members in, new SLOOH members in, so that we can do more of these shows.
Yeah, absolutely. I mean, that's what it's about, guys. You know, the more members we get, the more expansion we can have, and that's what it's all about. So, anyway, Paul, we've got about 4 minutes left. I mean, I think these shows are always fun to do, and it's great to have you on as always tracking this stuff, because I know it's not easy. As anyone can imagine, this object's 9 million miles away. It's only 3 football fields big, and that, you know, that's 300 yards in the U.S. and that 270, I guess, meters in everywhere else. And so, you know, you know, we're the only guys that use the other metric system. Don't use the metric system, but anyway, it's, you know, so it's not an easy thing to track, and it's neat to see it live and see how our solar system works all the time. Now, there is a lot of different things happening. SLOOH does do free shows. We do shows for our members. That's also part of being a member. You get guys like Bob Berman from Astronomy Magazine coming on. They'll give shows. We sometimes will pipe in his audio to the homepage now, where you can listen in. You won't be able to see some of the visuals all the time, but you know, that's the benefit of being a member. And there's a lot of different things that go on. So please do consider joining. If you can't join for whatever reason, look at a contribution angle. You know, anything's appreciated to help out, to fund this type of stuff.
Yeah, it is.
So anyway, guys, we're in our last few minutes here before it clicks over. You know, how do they measure, Paul? There's some questions rolling in. How do they measure an asteroid in space? I mean, how do they even get an idea how big it is? Is it just a gas?
It's purely because of its orbit. What we do is we take several images, right, like we've been doing tonight, and we measure its position. We know where the background stars are, so we measure the position of the asteroid very accurately in comparison to the background stars. We can then work out its orbit. When we've worked out its orbit, we know how far away it is from Earth, and the only way we can establish such a tiny object as this, its size, is to see how bright it is. So we measure the brightness of the asteroid as we're seeing it in an image like this in comparison to the stars in the background, and we already know their brightnesses very accurately. And we know that the average surface brightness of an asteroid is X, Y, or Z. We use that to calculate, to say, well, if it's that bright when it's that far away, it must be 310 meters in diameter. That's how we do it.
Right. That's wild. Yeah, there'll should be some images coming in. You know, there's a lot of people paying attention to this one because of the future. So we'll learn more over the, I don't know, coming weeks, I imagine, if not months, about if anything's changed in its orbit. I think the concern is for 2029 that somehow the orbit gets screwed up and it changes.
No, 2029 is fine. We have ruled out any possibility that it could impact in 2029. The uncertainty is still with that later pass.
Right.
That's what's uncertain. And part of the reason is, part of the things that make it so uncertain is we don't know how big it is yet. Hopefully some of the observations tonight will hone in on that a little bit more, but we don't know whether this object is rotating right rotating left, and that affects its orbit. We don't know the strength of the solar wind, which can push an object like that, forwards and backwards. Those are all of the uncertainties that we know, but we can plan out to 2029 and say, yeah, we're okay on 2029. But, Pat, we've got a great big one coming on February the 15th, haven't we? And we're going to cover that. So anybody who loves a near-Earth asteroid, that one is closer than man-made satellites. So that's going to be an absolute
that one
doozy.
is going to be crazy, because that's what we're definitely covering. Now, on the schedule right now, Paul, you've got a Stargazing Live #3 show, right, tomorrow?
Yeah, and tomorrow's show is all about comets and asteroids. This is the BBC are doing another 3 nights of live astronomy called Stargazing Live with Professor Brian Cox. I've been saying to people, he's my son. I taught him everything he knows about astrophysics and astronomy.
I thought that guy was just a model. Is he really? Does he know anything about space?
Yeah, well, I taught him how to play the keyboards as well, you see. But anyway, we're doing a follow-up show to those tomorrow, so that's quite early. That's at 9:30 English time, which I think is 1:30 or something, Pacific, something like that. But that's going to be cool, because we're going to be covering comets and asteroids. We're going to be talking more about Apophis and anything that we've learned from tonight, but also we've got the live universe show on Sunday night as well, where I'll be joined by SLOOH members coming in, and we're going to be looking at the best things that are coming up in 2013, Pat.
Okay, great. So I see on the schedule there's another one called Jupiter, but I guess that we'll just take that one out of the schedule, because that's
no, that I will be doing that. We've got some pretty cool stuff happening with Jupiter, and in fact tomorrow night is the big one for Jupiter. We are going to be tracking a double transit. We've got Io and I think it's Ganymede transiting, as well as the Great Red Spot. So tomorrow evening, in my show tomorrow, we're going to be showing some of that, but SLOOH members will get to see the end of that, obviously, because they've been controlling the scopes for that.
Oh, awesome. I didn't realize you're doing that. Okay, so you got the 2 shows tomorrow. So 2 shows tomorrow. One's counting down. And then you got the Stargazing one as well coming up, so that's coming on tomorrow as well. All right, guys. Well, we've got... that's going to wrap it up for tonight's presentation. If you're trying to watch this on the homepage now, there's no live feeds available. Please consider again joining. It's a great service. We've got
and it's great fun.
10 years behind us, with millions of photos taken, tens of thousands of members worldwide. So join and learn what's going on with SLOOH. All right, Paul. Well, have a good night. Thanks for your help tonight, and we'll talk to you this week.
Yep.
For SLOOH Space Camera, this is Patrick Paolucci. Thank you for joining. See ya.
Good night, everybody.
I always forget to turn off my phone.
Oh, that was yours, was it, in the last show?
Yeah. As much as I tell my wife, don't call me during a broadcast, it doesn't matter, man. She's always on. It's pretty funny. All right. Okay, we're going to start the SLOOH show with T-minus 1 minute. 1 minute. Hi everyone, this is Patrick Paolucci from SLOOH Space Camera. Thank you for joining us for show number 2, tracking Asteroid Apophis. It is January 9th, 2013. Thank you for joining us for our broadcast tonight. I'm here with longtime SLOOH outreach coordinator and engineer Paul Cox. He will be commanding our observatory in the Canary Islands. If you don't know where the Canary Islands is located, it's off the coast of Africa. We had a show earlier today, and due to the amount of interest worldwide, we decided to implement a second show. So I hope you guys are going to enjoy the view. Right now, if you're on the homepage of SLOOH.com, you can actually see the asteroid zipping through the sky. Now, as Paul outlined in the first show, and he'll screen share it in here for us quickly, so I'll make sure you guys can see it on the Hangout here for a little second. The best presentation is going to be on SLOOH.com. You can also see this Hangout interaction as well, but it's a little bit clearer view. So if you go to SLOOH.com, the SLOOH show is going to begin at T-minus 3 minutes. How did the Paul? How did the animation come out? Just curious.
Yeah, good.
Good. I'll get that out after this.
Yeah, I mean it's not as fast, obviously, as the other ones, but yeah, it looks okay.
Cool.
It actually comes up to a little galaxy. We didn't actually see it. It's in the images now as well. We've got a little background galaxy in there, which is looking pretty cool.
Oh, that's good. Let me just double check a few things. Okay, the SLOOH show is going to start in about 2 minutes. Okay, the SLOOH Space Camera show will begin in about 4 minutes. About 4 minutes. SLOOH show will start in 30 seconds.